Today I will be teaching you how to simplify radicals and use the square root method. The first examples of simplifying radicals are the square root of 64, the square root of 16, and the square root of 9. These are all perfect squares, so the answers will just be whole numbers. The square root of 64 is 8, so you can pull out two 8s. That means that your answer will just be plus or minus 8. The square root of 16 is 4, so you can pull out two 4s, so your answer is plus or minus 4. And the square root of 9 is 3, so you can pull out two 3s, so the answer is plus or minus 3. Our next set of examples are a little harder. They are the square root of 80, the square root of 175, and the square root of 28. These numbers are not perfect squares, so you have to factor them and pull out the pairs. For the square root of 80, first you can pull out a 2 and 40, then 2 and 20, then 2 and 10, then 2 and 5. So if you look at this, you can circle the pairs of 2's, and after you circle the pairs, you end up with two pairs, meaning you have two 2's that can go on the outside. Then you would multiply the two 2's, and 4 would become the number that goes on the outside of the square root. You are left with a 5, so a 5 will stay inside the radical. So your answer will be plus or minus 4 times the square root of 5. For the square root of 175, you can pull out a 5 and 35 and a 5 and 7. If you look at this, you can see one pair of 5. Then you would bring a 5 to the outside of the radical and leave the 7 inside. So you only had to do one step. Your answer is plus or minus 5 times the square root of 7. For the square root of 28, you can pull out 2 and 14 and 2 and 7. That leaves you with a pair of 2's. Then the 2 would go on the outside of your radical, giving you plus or minus 2 to the square root of 7. For this last set of radicals, you can see that these are different. They are negative numbers. These numbers are negative, which introduces a new element to simplifying radicals, known as I. I is an imaginary number that we use to substitute the negative. So, for our first number, we have the square root of negative 512. You have to pull out a negative 1 and 512 first, then factor it normally. So 2 and 256, 2 and 128, 2 and 64, and so on. Then you are going to circle your pairs of 2's. After this, you will bring down your pairs of 2's and multiply. So you will multiply 2 times 2 times 2 times 2, and you are left with 1, 2. After multiplying these 2's, you get 16. So your number on the outside of your radical will be 16, and you will have 1, 2 inside your radical. So that your answer is plus or minus 16 to the square root of 2i. I stands for your negative. For the square root of negative 36, you will first pull out a negative 1 and 36. 36 is a perfect square, so you can pull out two 6's that forms a pair. So your answer is just going to be plus or minus 6i. For the square root of negative 147, first you will pull out a negative 1 and 147, then a 3 and 49, and that is a perfect square, so two 7's. This forms a pair, so 7's will go on the outside of our answer. We are left with a 3 on the inside, and the negative 1 turns into an I. So our answer is just going to be plus or minus 7 to the square root of 3i. Note that the I is actually on the outside of the radical. The square root method is used when a quadratic equation is missing a middle term, the bx. You would also use this method if you are given an equation set up like x squared equals a number. When the square root method is used, it is common to get non-real or complex solutions. The first step is to add or subtract your constant to both sides, if necessary. The second step is if your variable has a coefficient, divide both sides by it. Your third step is to take the square root of both sides. Your fourth step is if the number inside your radical is negative, replace it with an I. And your fifth step, if your number within your radical can be simplified, do so, following the rules from earlier in the video. Here are some problems that you can use the square root method for. For the first one, x squared equals 25, you could skip the first two steps and just start with taking the square root of both sides. That will give you x equals plus or minus 5. For the next one, it's 3x squared minus 27 equals 0. You could see you're missing the middle term. You will add 27 to both sides, giving you 3x squared equals 27. Then you will divide both sides by 3 to get rid of the coefficient. That gives you x squared equals 9. Finally, you will take the square root of both sides, giving you x equals plus or minus 3. For the next problem, 2x squared plus 140 equals 0. You will subtract 140 from both sides, giving you 2x squared equals negative 140. Then you will divide both sides by 2 to get rid of your coefficient. That will give you x squared equals negative 70. Now you will take the square root of both sides. But because negative 70 is not a perfect square, you will have to factor it. So, for negative 70, it is negative, meaning you have to pull out a negative 1 and 70, then 2 and 35, and then 5 and 7. This tells you that the number is actually prime, meaning that you have to keep the 70 inside, but you can pull out the negative 1 as an I. So your final answer is x equals plus or minus the square root of 70i. For our last example, we have x squared minus 59 equals 0. You will add 59 to both sides, giving you x squared equals 59. Then you will take the square root of both sides. 59 is not a perfect square, so you will have to factor it. But to save you from some work, you can look at it and see that there are not factors of 59, meaning it is prime. So your answer will just be plus or minus the square root of 59.